Hello students, welcome to today's session. Today we are going to discuss about the most important electrostatic force. So generally in the last session we discussed about the charge and properties of charge and also how we can make the charging of the bodies, process of charging. So we'll discuss about electric force, electrostatic force. This is also named as electrostatic force. So we know that well-known process is Newton's laws of gravitation. Similar, that is in between the masses, and this is between the charges. This is between the charges. So it was proposed by the Coulombs. So that's why this name is named as Coulomb's law. Coulomb's law. Coulomb's law says that the force of attraction or repulsion between any two charges, the force of attraction or repulsion between any two charges is directly proportional to product of their magnitude of the charges and inversely proportional to square of distance between them. Here I am considering two charges Q1 and Q2. Q1 and Q2, whatever the charge, even positive or negative. If those are like charges, then repelling each other. Those are unlike charges, then attracting each other. Repelling and attracting. So see here what we are considering, two charges are separated by a particular distance. Then the force of attraction or the force of repulsion is directly proportional to product of their magnitude of the charges. The force of attraction or the force of repulsion is directly proportional to their magnitude of the charges. Magnitude of the charges Q1, Q2 upon and inversely proportional to square of distance between them. Inversely proportional to square of distance between them. When the distance between the charges increases, then the force will be decreases. When the magnitude of the charge increases, then force also increases. So see here, F is directly proportional to Q1, Q2. F is directly proportional to 1 by R square. So then F is equal to, or F is directly proportional to Q1, Q2 upon R square. F is directly proportional to Q1, Q2 upon R square. Then F is equal to what we can able to write 1 by 4 pi epsilon naught Q1, Q2 upon R square. 1 by 4 pi epsilon naught Q1, Q2 upon R square. What is this 1 by 4 pi epsilon naught? What is this epsilon naught? Epsilon naught is the permittivity of the free space. Epsilon naught we can name it as permittivity of the free space. Permittivity of free space. Permittivity of free space. Epsilon naught is permittivity of free space. So actually if you are taking the epsilon naught value, you have 8.85 into 10 to the power of minus 12. So unit is going here, then the force is coming here. Coulomb square for Newton meter square. Coulomb square for Newton meter square. 8.85 into 10 to the power of minus 12 Coulomb square for Newton meter square. That is the unit of epsilon naught, and the value of that 8.85 into 10 to the power of minus 12. If we are try to simplify this value, 1 by 4 pi epsilon naught value, you are getting here 9 into 10 power 9. 9 into 10 power 9. 1 by 4 pi epsilon naught. This value, only this value. This particular value, how much you are getting? 9 into 10 power 9. If you want to check, you can just put the value of this, then you are getting 9 into 10 power 9. 9 into 10 power 9, because it can help during the solving of the numerical problems. Okay, comes here. What is this permittivity? What is this permittivity? How the permittivity is work out here? The permittivity is nothing but the property of medium which can influence the force between the two charges. Which can influence the force between the two charges means, what is the meaning of that? Here I am considering a positively charged body, and here I am considering a negative charge. So generally what is happening here? Positive charge and negative charge, the way attract each other. Yes, right. You know that. In case in the middle of them, if I put a conductor, then what happen? Yes. This both charges, when we are comparing with the conductor particles, this conductor can attract the two particles. That means automatically the force between the charges will be yes, influenced by the medium. If there is no medium, that is called free space. If there is no medium, that is called free space. In this free space, epsilon naught value is this much. Is epsilon naught value. Epsilon naught is the permittivity of the free space. What is a permittivity? What is permittivity? Permittivity is the property of the medium which can influence the force between the two charges. Which can influence the force between the two charges. That is called simply permittivity. So here, whenever we put any medium, that's not a conductor, insulator, any medium if you are placing there, so then automatically there is some change is there. There is some change because of the medium is influenced the force between them. That particular property we can call as there is, which creates some intercurrent. That we can say that simply permittivity. And the permittivity for the different mediums, it is different here. For example, here I am considering two charges without medium. In case if I am considering two charges with medium, I am placing there is a medium of the dielectric constant K. What is this dielectric constant? No problem. Let's see here. So we put in a medium and that is K. Then force between them is also directly proportional to Q1, Q2. But what is happening here? There is we are taking not epsilon. Epsilon naught is the permittivity of the free space. But here we are taking epsilon into Q1, Q2 by R square. What is epsilon here? Epsilon is the permittivity of the given medium. Epsilon is the permittivity of the given medium. Permittivity of the medium. Now here only we are giving the definition for the dielectric constant or relative permittivity, where K is called dielectric constant or relative permittivity. What is the definition for that? The permittivity of the medium, the ratio of permittivity of the medium to the permittivity of the free space. The ratio of permittivity of the medium to permittivity of the free space is called simply relative permittivity or dielectric constant. That is equal to, actually K is equal to epsilon by epsilon naught. Then epsilon is equal to what we can able to write? K into epsilon naught. This value just put here. Then what we are getting here, the force. The force goes to 1 upon 4 pi epsilon naught, and the distance also R only. Take distance is R only. So 1 upon 4 pi K into epsilon naught Q1 Q2 by R square. K into epsilon naught Q1 Q2 by R square means nothing but in the free space how much you got? 1 by 4 pi epsilon naught Q1 Q2 by R square in the free space. So now in the medium how much we got? F upon K. F upon K. Due to the medium, the force is influenced, the force is decreased. So if K is a conductor, generally for conductor what is the K value? Infinity. For insulators means like air, K value 1. For generally K value we can take 1. In the free space we are considering air or free space, the value we can take 1. But for conductors, what is happening? The K value is infinity for conductors. Whenever it is having infinite value, something upon infinity, it becomes 0. So whenever we can consider two charges are separated, and in the middle if you put conducting medium means two charges are separated in a conducting medium, then what is the force between the two charges? The force between the two charges is goes to 0 because of the conductivity, the dielectric constant of conductor is infinity. Take something upon infinity is 0. So that is simply we can take as dielectric constant. Dielectric constant is also named as K is called dielectric constant here. K is dielectric constant. Dielectric constant. Dielectric constant means which is having the ratio of the ratio of permittivity of the given medium to the permittivity of the free space is called simply dielectric constant or relative permittivity. By the influence of that, the value will be decreases to k times. So we'll see here, whenever if you put a medium is presenting between the charges, so then what about the value? For example, here what I am considering, first I am considering the charge. Two charges are separated in free space. In free space, Q1 and Q2 are the two charges are separated in a free space. Free space means where K is equal to 1 and epsilon naught by a distance R naught. R naught represents in free space. Next, what I am doing, now here that can produces the force is equal to 1 by 4 pi epsilon naught Q1 Q2 upon R naught square. Now what I am doing, I put some dielectric constant between them, but I am not changing the magnitude of the charges. I am not changing the magnitude of the charges, but by the variation of the distance, we know that by the distance decreasing force will be increases. Distance decreases, force is increases. Now I am decreasing the distance to R, distance between the charges I am decreases to R. So now the force is equal to F. Now the force is equal to F. Then what about the relation between R and as well as K and R and as well as R naught relation? Means what happened here, first we kept in free space, distance is R naught. Now I put in a medium and the distance is decreases. Distance is decreases. Due to the decreasing distance, force is increased, but due to the medium, force decreases. So that's why the total force is remains constant. Force is remains constant in both cases. Force remains constant. But what is the variation is distance. So first I put it a distance of R naught. Next, it is separated by a distance of R. So now forces are equal, just equating the both forces. If we are equating both forces, 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught, Q1, Q2, Q1, Q2, everything is cancelled and remaining what you have, 1 by KR square is equal to 1 by R naught square. Then KR square is equal to R naught square. Then R square is equal to R naught upon K. Then R is equal to simply R naught upon root K. R is equal to simply what we can able to take, R naught equal to simply R upon root K, or else R naught equal to root K times of R. So this is called generally effective distance. Effective distance, whenever if you separate the charges, or if you are placing in the dielectric medium and without medium, if you want to produce the same charge, if you want to produce the same force, so that time you need to decrease the distance from R naught to R. The ratio of R naught to R is root K times. Next, we will take the vector notation for these forces, vector notation for these charges. For example, here in case if I am considering two charges, two like charges. What about the force between two like charges? Which kind of force? Repelling force. Repelling means we can give the numbering like 1 and as well as 2. 1 and as well as 2. Q1 and as well as Q2. Or the two like charges. Now how it is happening? 1 can repel 2. At the same time, 2 can repel 1. Nothing but the force on 1 by 2 in which direction? This direction. That's we are giving simply F12 means 2 is repelling 1. Next, at the same time 1 also repels 2 na? This is F21. F12 and as well as F21, because repelling means the force is acting away from each other. Repelling means the force is acting away from each other. So that simply we can take it as F12 and as well as F21. F12 and F21 magnitudely equal here. Magnitudely equal, but directionally opposite to each other. Magnitudely equal, but directionally opposite to each other. Next, second, you can take one negative charge, take two negative charges also, no problem. Just use, you observe two positive charges, then you can take two negative charges, Q1 and as well as Q2. Two negative charges. Then again what happens? Repulsion takes place. One can repel two and two can repel one. Means F12 force on 1 by 2. F21 force on 2 by 1. F12 force on 1 by 2. F21 force on 2 by 1. So both are repelling each other. Again these also equal in magnitude, opposite in direction. The next case, these are like charges here. Like charges. Force between two like charges. And take two unlike charges. Unlike charges, like charges are enemies, dushman. Like charges. And like charges are friends, dost. So here like unlike charges means taking here one positive charge of Q1 and another negative charge of Q2 are separated by some distance. Now what happened? The Q1 will attract Q2. Q1 is attracting Q2. Q2 is attracting Q1. F12 and F21. Please observe here. What is happening? Both are attracting each other. So this will be goes to the force of F12, force on 1 by 2. 2 can attracting 1 at the same time. 1 can attracting 2. F12 and as well as F21. F12 and as well as F21. Force on 1 by 2 and force on 2 by 1. So this is simply we can take it as vector notation for that. And also what is the magnitude? The magnitude of the both forces is same. So this is between two like charges and between two unlike charges. We will take three charges. So we will see three forces, three charges, three like charges, just I am not taking only magnitude, just I am taking the vector notation. Three like charges. Like charges are placed at the three corners of triangle, whatever the triangle, three corners. Here I am taking plus Q1 plus Q2 plus Q1 plus Q2 and as well as plus Q3. Three charges we placed at the three corners of the triangle, whatever the triangle is, it equilateral or whatever the matter it is, but it is a triangle. So then what is happening here? Three charges, one Q1 and it is Q2 and this is Q1 and this is Q3. Then how the forces are acting? For example, these are like charges, means either positive or negative. Now what is the force direction between 1 and 2? First of all, so 1 can attract or repel. Yes, repel. Force on 1 by 2. This is the direction. Force on 1 by 2. That's the direction. Here, force on 2 by 1. Force on 2 by 1. This is the direction. Yes or no? Yes. One is attracting, one is repelling 2 and 2 also repelling 1. So that's why this is the direction of the force both. And what about this? Here 2 F32, force on 3 by 2. And this is F23, force on 2 by 3. Means 2 is repelling 3. 3 also repelling 2. See the directions. And comes to this 2. Now these are also like charges. Means 3 repelling 1. Force on 1 by 3. And 1 also repelling 3. Force on 3 by 1. Force on 3 by 1. See here. Force on 1 by 3. Force on 1 by 2. Force on 3 by 2. Force on 3 by 1. Two forces are acting. Here also two forces. Means 3 charges are there. Then force on any one charge is how many forces acting? 2 forces. By remaining 2 charges. These may attract or these may repel. For example, if one of the charge is negative, means this Q1 positive, Q2 I am considering negative and Q3 is positive. For example, Q3 positive. These three are placed at the three corners of the triangle. So then what about the direction of the forces? Take only the direction. No, don't take magnitude. Take the direction. So what is the force between these two? These two are repelling each other. Sorry, this is negative, I said. Negative. Q2 is negative. When Q2 is negative, then automatically what is the force existing between these two? Between these two is attracting. Because these two are attracting each other with what force? F21 and as well as F12. These two are attracting each other. What about these two? What about these two? These two also attracting each other because Q1 minus Q2 and plus Q3, right? Between Q1 and Q2, attraction. This is F21, this is F12. Between Q2 and Q3 also attraction. F23 and F32. Between Q1 and Q3, repulsion, because these two are like charges, but these two are unlike. These two are like. So then this is the direction of F31. This is the direction of F13. So like that the forces are acting. So taking three charges, and whenever if the magnitude of the charge changes, means if you are taking negative, then automatically the direction of the force also changes. So we'll solve one problem here. If three charges are identical placed at the three corners of the equilateral triangle. See here the question is three identical charges. Write down the problem. Three identical charges are placed at the three corners of an equilateral triangle. Three identical charges are placed at the three corners of an equilateral triangle. Then what about the force on any one charge? Identical charges are placed at the three corners of an equilateral triangle. Three corners of an equilateral triangle. Then what about the force on any one charge? Here we are considering three identical charges. Means magnitude must be same, and also the direction also must be same. Direction means nothing but value of the Q, that is also must be same. Q1, Q2, Q3. You can give numbering 1, 2, 3 like that. Now you can try to get what is the force on this charge. Force on this particular charge. See here how many forces are acting on the third charge? Two forces. Attraction or repulsion? Attraction or repulsion? Yes, repulsion only, because like charges. See here, this is the force on 3 by 1. This is the force on force on 3 by 2. So here I want to find only what is the force acting on any one charge. Force acting on any one charge. You can take any charge, not only 3. You can take 2 or you can take 1. Force on any one charge is I am going to take. So here try to get means equilateral triangle means all sides are equal na? A and as well as A. So please take the value of F31. 1 by 4 pi epsilon naught Q1 nothing but Q3 Q only by how much distance? A square. So what is the value you are getting? Simply 1 by 4 pi epsilon naught Q square upon A square. This is F31. At the same time write F32 by this F32. This is the second and this is third. So how much you are getting? 1 by 4 pi epsilon naught Q2 Q3 upon A square, because distance is A. So this is also getting F32, also you are getting 1 by 4 pi epsilon naught Q square upon A square na. This is q square upon a square. This is also q square upon a square. Means these two forces are equal in magnitude. Means nothing but what about the direction? F32 is equal to F31 is equal to, I am considering like F. Magnitude, I am considering like F. So now see here what is happened. This is F force and this is also F force. The force is a vector component now. Yes. What is the angle between them? What is the angle between them? This is the angle between them. How much? This is how much? 60. Then this is also 60. That is also 60. Now the two forces are, angle between two forces is 60. Then what about the magnitude of the resultant vector? The magnitude of the resultant vector under root f square plus 2f into f cos theta. Cos 60. You can apply the magnitude of the resultant vector. The magnitude of the resultant vector formula a square plus b square plus 2ab cos theta. A square plus b square plus 2ab cos theta. Then the magnitude of the resultant vector you are getting f square plus f square 2f square. Nothing but 2f square plus 2f square into cos 60. Cos 60 how much? 1 by 2. 2 to cancel. Then finally what is the resultant force is root 3f. What is the resultant force? Root 3 times of f. Root 3 into f value 1 by 4 pi epsilon q square upon a square. 1 by 4 pi epsilon q square upon a square. So this is the force. Three identical charges are placed at the three corners of an equilateral triangle. Then force on any one charge is root 3 times of f. So for example, in this what I am doing, I am just changing one value. I am just changing one charge. Means two like charges and one unlike charge. Two like charges and one unlike charge. I am taking Q1 is a minus, Q2 is a plus, and Q3 also plus. Then what about the force between them? Force on Q3 by remaining 2. Same question here. Same question continuation what I am taking here. One charge is replaced by the negatively charged. Then what about the magnitude of the charge? See here, these two charges are repelling. Force on 3 by 2, no change. But what about the force between 1 and 3? Yes, 1 is negative, 3 is positive. Then both are attracting each other. This is the force on 3 by 1. Now what is the angle? This angle is how much? 60. Then this angle is going to be 120 because total angle is 180. So that angle is 120. Means what is the angle between in the previous F31 and F32 angle is 60. Now what is the angle is 120. When the angle is 120 and also if there is no change in the magnitude, again equilateral triangle only. So that's why you can take the value of F31 is equal to F32. You can take the same value here. Magnitude of the force is same. Because we are not changing the value and as well as the distance. But only we are changing positive charge by the negative charge with the same value. So now see here. The force between them is, angle between the forces is how much? 120 degrees. Then the resultant force equal to under root. These two forces is equal to, I am considering F. Nothing but F square plus 2 into F into cos 120. Means F is nothing but F31, F32, and that's only. I am taking like that. Then the resultant force equal to how much you can get. See here, this is a 2F square and this is a 2F square. But here you are getting cos 120 minus 1 by 2. Cos 120 minus 1 by 2. So then 2 gets cancelled. Then you can get the resultant force equal to simply 2F square minus F square. Nothing but root F square. The value is F. Whenever if you are replacing with another charge, then the force on this charge is changed to F. 3 unlike charges, root 3F. So 3 like charges, root 3F. If one unlike charge is there, so the value is changes to like this. So let's we discuss about the 4 charged particles are placed at the 4 corners of the square. Then what is the force acting on any one charge? So let's see the situation here. Here we are considering 4 identical charges, Q, Q, Q and as well as Q. 4 identical charges are placed at the 4 corners of the square. 4 corners of the square. So now here what is the force acting on this charge 3? What is the force acting on charge 3? So see here, first of all, you can consider the side of the triangle as, side of the rectangle, square as A. So here, the force on 2 by 1, which kind of force? These two are like charges. Like charges are repelling each other. So the repulsion, F3, 2, force on 3 by 2. And this force is F3, 4, force on 3 by 4. F3, 4 and as well as F3, 2. F3, 2, force on 3 by 2, force on 3 by 4. Arey, kitki band kara. So, गरम है इसलिए. So F32, F31. So इसका रिजल्टेंट क्या हो जाएगा वो बाद में देखेंगे. So let's see here, another force is there. Yes, which force? Force on 1 by 3. This is a F31. Force on 3 by 1. Force on 3 by 4. This is the direction, vector notation. Force on 3 by 2, it is the vector notation. Force on 3 by 1, it is the vector notation. नींद आ रही क्या? नींद आ रहे? सुनो अच्छे से. So let's see here, F34, force on 3 by 4 and force on 3 by 2, both are same because equal in magnitude and equal in same direction, same distance and as well as same direction. So that's why what we can able to write, the value is 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught, q square upon a square, 1 by 4 pi epsilon naught, q square upon a square, which is equal to, we can consider F, because these two forces are equal and both our magnitude is q only, same distance. So that's why that is F. And also take F31, force on 3 by 1. So the value is 1 upon 4 pi epsilon naught. पहले distance निकालो, कितना distance? ये और ये कितना हो जाएगा? √2a from Pythagoras theorem. Side square plus side square, opposite square plus adjacent square is equal to hypotenuse square, √2a. So अब ये distance का बताओ, q square upon √2a whole square, q square upon √2a whole square. So क्या हो जाएगा? 1 upon 4 pi epsilon naught q square upon 2a square, q square upon 2a square. अभी देखो 1 by 4 pi epsilon naught q square by a square का वैल्यू कितना है? 1 by 4 pi epsilon naught q square by a square वैल्यू कितना है? F होगा और पूरा वैल्यू कितना होगा? F by 2. पूरा वैल्यू कितना होगा? F by 2. So अभी देखो इधर, what are the forces acting on 3 force ये है और पहले force on 3 by 4, force on 3 by 2, these two are perpendicular to each other. Yes or no? Yes. So this value is F and this value also F. These two are perpendicular to each other. Then its resultant निकालो पहले. दो vectors are perpendicular to each other. Resultant क्या हो जाएगा? Under root 3f2 square plus under root 3f34 square. So अभी उसका वैल्यू सब्स्टिट्यूट करो, कितना आएगा? f square plus f square कितना आ जाएगा? √2f. So this is the value of the resultant of 4 and 2 on 3. और एक फोर्स देखो, कौन सा फोर्स एक्ट हो रहा है इधर से? F31. कौन सा डायरेक्शन में? A डायरेक्शन में F31. और अभी टोटल फोर्स लीजिए, कितना फोर्स एक्ट हो रहे हैं? F net is equal to net force, मतलब टोटल फोर्स एक्टिंग ऑन इट कितना है? Fr प्लस F31 कितना आया था हमको? F31 इक्वल टू F by 2, F3 √2f F31 F by 2. So F common लीजिए, root 2 plus 1 by 2. This is the value of the net force. The net force acting on the third charged particle. Net force acting on the third charged particle. समझ में आया ना? आया ना? Very good. और एक एग्जाम्पल लीजिए हमने. इधर क्या कर रहा हूं मैंने? पहले चार्ज है Q1, उसको नेगेटिव से रिप्लेस करो. नेगेटिव 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 पॉजिटिव नहीं होगा. नेगेटिव नेगेटिव रिफ्लेक्ट हो जाएगा, सॉरी रिपल हो जाएगा. और मैंने क्या किया था इधर? फर्स्ट चार्ज से नेगेटिव निकल पॉजिटिव निकल के नेगेटिव रखा है उधर. क्या? पॉजिटिव निकल के नेगेटिव चार्ज रखा है. अभी Q3 इसके ऊपर क्या हो जाएगा? फोर्स. चलो देखो इधर अगेन नंबरिंग 1 2 3 4. नंबरिंग 1 2 3 4. इसके ऊपर कितने फोर्स एक्ट हो रहे? फर्स्ट F3 2 फोर्स ऑन 3 by 2. नेक्स्ट F3 4 फोर्स ऑन 3 by 4. फोर्स ऑन 3 by 4. कौन सा डायरेक्शन? दोनों वैसा है. उसका रिजल्टेंट यही रिजल्टेंट. रिजल्टेंट का वैल्यू बताओ. √2F. कैसा? यहां से √2F. वही है ना रिजल्टेंट दोनों का. यस. और दूसरे फोर्स 1 और 3 के बीच में कौन सा फोर्स एक्ट हो रहा है? अट्रैक्शन और रिपल्शन? अट्रैक्शन. क्यों? नेगेटिव और पॉजिटिव. एक नेगेटिव और दूसरे पॉजिटिव. सो दोनों के बीच में कौन सा फोर्स एक्ट हो जाएगा? अट्रैक्टिव. कितना? F31. F3 का वैल्यू बताओ. कितना? F/2. कहां से? यहां से. फ्रॉम हियर वी टुक F/2. किधर गया था क्लास छोड़ के? बीच में F/2 और ये √2F. दोनों कैसा एक्ट हो रहे? दोनों इधर उधर दोनों अपोजिट अपोजिट एक्ट हो रहे ना. सो अभी द रिजल्टेंट और द नेट फोर्स इज इक्वल टू F31 और Fr माइनस F31. Fr वैल्यू कितना है? √2F. F31 कितना है? F/2. F कॉमन निकालो. √2 minus 1 by 2. This is the value of the net force acting on the charge, third charged particle. బంద్ చేయమని అర్థం. సైలెంట్ గా నిలబడితే So we'll take one more problem here. What we are doing? We can take 4 charges, but 2 negative, 2 positive. 2 negative, 2 positive. So what are that values taking? 1 2 3 4. What are the forces acting on 3 by remaining forces? Just I am giving the direction. Let's see here. So these two charges are attracting each other, right? What is that? F32. These two charges are attracting each other. F34. And these two charges are repelling or attracting? Repelling each other with a force of, what is the value? Fr means F31. Now what is the resultant of these two? These two are perpendicular to each other. Its resultant act हो जाएगा. रिजल्टेंट क्या आ जाएगा आपको? √2F. इसका रिजल्टेंट क्या आ जाएगा? √2F. और इसका वैल्यू कितना आ जाएगा आपको? सिंपली F/2. F/2 and as well as √2F. Then the net force is equal to simply Fr minus F31. So again, what is the value? √2 minus 1 by 2 of F. So whatever you are taking here, only direction will be changes. Magnitude remains constant. We are considering, then the direction is changes from here to there. Okay, let's see. We are taking one more problem. So up to now, what we discussed? We discussed 4 charges are placed at the 4 corners, and as well as charges are placed at the 3 corners. So we'll see what is the force acting on a charge which is placed at the center. See here, what I am doing here, I am considering 4 charged particles, plus Q, plus Q, plus Q, and as well as plus Q. What I am taking here, another charge Q I am placing here. What is the force acting on Q by the remaining 3 charges, remaining 4 charges? What is the force on? Force on Q. Force on Q. What is the force on Q? See here, how many charges are there? 4 charges. 1, 2, 3, 4. How much distance? Yes, all are having same distance. How much distance? For example, if we decide A, this is also A, this is also A, and as well as this is also A only. A. ओए नहीं गलत आराम से सुनो, बताओ क्या है फॉर्मूला इसका? फॉर्मूला बताओ फॉर्मूला. Okay, see here, what is the force on Q by the remaining charges? See here, these are, for example, this is also plus. Which kind of force is acting? See here I am giving the direction. This is the direction of, this is you are giving fifth charge. The force on fifth charge by first charge. Force on fifth charge by first charge. This is the direction. Force on fifth charge by third charge. F3 3. Yes or no? These two are acting away from that. The force on fifth charge by fourth charge. F5 4. Force on fifth charge by 2. This is the direction. Because these are identical charges. Identical charges बोले तो क्या हो जाएगा? रिपल हो जाएगा. ये दोनों रिपल एक्ट हो जाए, इसका फोर्स ये डायरेक्शन होगा. ये दोनों रिपल हो जाएगा, ये दोनों रिपल हो जाए, इसका डायरेक्शन ये होगा. और ये दोनों रिपल हो जाएगा, इसका डायरेक्शन ये होगा. ये दोनों रिपल होगा, इसका डायरेक्शन होगा. Means these are all repelling each other, so that's why the directions are like this. So now we can observe all are separating from the same distance. Nothing but the magnitude of the forces are same. Magnitude of the forces also same. If you want to check, you can check. What is the distance here you are getting? The total value is, this total value A. How much? Root 2A. इसका आधा लीजिए, means by 2, मतलब A by root 2. How much? A by root 2. Now what is the force? You can check, no problem. F1. How much? 1 upon 4 pi epsilon naught. K I am considering. Q. Capital Q. Small q. By A by root 2. Nothing but A square by 2. So like that you are getting. 2 you can take here. At the same time find F5 force. F5 K into Q by A by root 2 ना, nothing but A square. मतलब क्या हो जाएगा दोनों? Net force in this direction 0, in this direction 0. That finally the force on Q, capital Q, becomes force on capital Q is equal to 0. Force on capital Q is equal to 0. 4 forces, 4 charged particles are placed at the center. Then the net force is acting on it. It should be 0. In case take 3 charges. 3 charges are placed at the 3 corners of equilateral triangle. Then what about the net force on that? Net force on that. That is also becomes 0 because all are acting from the same axis. All are acting from the same axis or same distance. Let's see. One more example we will take. One more example we will take on the force. Yes. What is that? See here, I am considering here one circular sphere and here one circular sphere. Of this radius is R. This radius is 2R. This radius is R. We are taking different charges. Here I am placing a negative charge. And I will take the big diagram because we need to understand properly. So this is one charge, one circle, and this is another circle. The radius of the first circle is capital R. The radius of the second circle is 2R. Now here I am placing a negative charge, but here I am placing the charges. Here plus Q, here minus Q, here plus Q, here minus Q, here plus Q, here plus Q, right? Here plus 2Q, here plus 2Q, here plus 3Q, here plus 3Q, right? And one more take here, diagonally like this. Here plus 4q, here also plus 4q, and here take, here plus 5q, here plus 5q. These many charges are there. How many charges? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 forces are, 12 charges are placed at the different places of the square circle. And there is a negative charge which is placed at the center. Then what about the force acting on the negative charge? What about the force acting on the negative charge? First we will start from which charge? From outside charges we will take. First, this is the negative charge I am considering, minus q. Now, this 2q is separated how much distance? 2r distance. 2r distance. This is the 2q. Which kind of force is acting? This is a plus and this is minus. Attracting force. कौन सा डायरेक्शन में? ए डायरेक्शन में. कितना आ जाएगा मैग्नीट्यूड? 2r डिस्टेंस. और चार्ज कितना है? 2q and as well as q. Same means for example F force is coming. और नीचे देखो इधर कितना डिस्टेंस पे? यहां से यहां तक. Again 2r. Attraction or repulsion? Attraction, because this is also plus. So इस तरफ plus. और इस तरफ F plus q. F और इस तरफ F. What is the force about the plus 2q? Plus 2q. The force is goes to plus 2q. अब कैसा निकालना है इसको? Simply F 1 by 4 pi epsilon naught q1 q 2q by 4r square. This is also same. Means एक नीचे और एक ऊपर. कितना हो जाएगा? 0. ये दोनों चार्जेस का फोर्स इसके ऊपर 0. ये दोनों चार्जेस का इसके ऊपर 0. क्योंकि 3q r distance, 2r distance, and 3q 2r distance, 2r same distance, 3q 3q cancel. Next 4q cancel, 5q cancel, 4q 5q also cancel. Remaining q and q also cancelled. Then what is the final remaining? Plus q and as well as minus q. Let's see what are the forces acting on that. This is a minus q and this is a plus q, are separated by distance r. This is also r. Let's see what is the force between these two forces. What is the direction? Attraction. Between these two forces, what is the direction? Repulsion. What is the direction? Repulsion. So let's still take the value. So give 1 2 3 force on 2 by 1. What is the direction? This 1 by 4 pi epsilon naught. I am taking k. 1 by 4 pi epsilon naught q into q by r square. Q into q by r square. Plus at the same time f 2 3 force on 2 by 3 k into q by r square. Q into q by r square. So that means these two are acting in the same direction. Then the net force on q is equal to 1 by 4 pi epsilon naught 2q upon r square in this direction. So that is the sum of the forces acting on the charged particles. So we'll see here one more condition. Up to now what we discussed, different forces acting on it. Now what I am taking here, I am considering two identical spheres are dropping by two insulating strings. Just we are releasing two identical charges, either positive or negative. So now what happened? Those two are repelling each other, and due to the repulsion, those are making particular angle here. So if they are making an angle theta with the vertical, then what about the magnitude of the charge? Means you need to find magnitude of the charge. Chalo question likho here. Write down the question. Two identical charges are suspended from a rigid support by insulating string if the string is making an angle theta, if the string is making an angle theta with the vertical, and length of the string is L, length of the string is L. If the string is making an angle theta with the vertical and the length of the string is L, then find the magnitude of the charge, find the magnitude of the each charge. Okay, let's see the question. What they mention here, these two are identical. I am considering plus Q and as well as plus Q are suspended by the massless insulating string. Insulating means it's not attracting and it's not repelling the charges. Our length of each string is L. Length of each string is L. So due to the repulsion, what happened? Those are going like that, and they are under equilibrium. Then only they can able to make an angle theta. So then only they can able to make an angle theta. So let's see what are the forces acting on this. What about the directions? Again, this is the given diagram, but for our convenience, I am drawing very clear diagram. See here. So this is the first charge. You can consider one charge enough. What is the weight? Downward direction, mg. And here in that string, tension will act now. Yes, tension will act, and that tension is making an angle theta. So that's why tension can be resolved into two components. What are those? T cos theta and as well as T sin theta. Here also same, T cos theta and as well as T sin. लेकिन यहाँ पे ऑब्जर्व करो, इधर ये बॉडी इधर जाने का कारण क्या है? Means what is the reason to move from this side? The charge is nothing but electrostatic repulsion, because those are identical charges. So that's why those are moving like that. Here what is the force acting? That force is electrostatic force. So this is the angle theta. At the same time, try to get the length. मतलब इधर same act हो जाएगा with both identical charges, and this is L. This is क्या हो जाएगा? L. So then this will be goes to L sin theta. What is that? From here to here, L sin theta. You can consider X, and this is also L sin theta. Or here also same conditions are applied because same identical charges. So let's see here on this diagram what are the forces acting. इसमें क्या क्या forces act हो रहे? देखो इधर कौन सा forces act हो रहे? Weight is acting downward direction. mg is equal to T cos theta, and electrostatic force is acting F equal to T sin theta. F equal to T sin theta. You have tension? No. So that's why write the value of Fe. Fe is equal to 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught. Q1 Q2 by R square, nothing but 2x square. Q यहाँ से यहाँ तक x और यहाँ से यहाँ तक भी x, दोनों कितना हो जाएगा? 2x होल स्क्वायर. सो अभी क्या हो जाएगा? F इक्वल टू 1 by 4 pi epsilon naught Q square upon 4x square. x का वैल्यू सब्स्टिट्यूट करो. x का वैल्यू कितना आ जाएगा आपको? x is nothing but x equal to simply L sin theta. x equal to L sin theta. So then Fe is equal to 1 by 4 pi epsilon naught Q square upon 4 into L square sin square theta. This is the take equation 1. Now see here. Take here just take the ratio of T sin theta upon T cos theta, which is equal to Fe upon mg. T cancel, कितना आ जाएगा? tan theta is equal to Fe, मतलब ये पूरा वैल्यू सब्स्टिट्यूट करो. कितना है पूरा वैल्यू? 1 upon 4 pi epsilon naught Q square by 4L square sin square theta upon mg, nothing but into mg. Now what is our requirement is Q. So that's why except Q square remaining you can send that side. Then what we are getting? 4 4s are 16. 16 pi epsilon naught L square sin square theta mg into tan theta. So then Q value how much you are getting? Under root 16 pi epsilon naught L square sin square theta mg into tan theta. Yes. So this is the session related to electrostatic force. In the next session, we'll discuss about electrostatic field.